one step, well, I kind of skipped one step equations because I don't think you need it, but two step equations. So we talked um, about guiding, right? This is like a little guide, that little story that you created. I mean, I call it story, call it whatever you want, but it's just a little plan, a little map that's going to tell you what to do. So for this one, and I'll do it over here. So think about that problem I asked in the beginning of class. I'm thinking of a number, I multiply by this, and blah, 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 blah. And then Veer went and did the inverse operations, and he went backwards to come up with the starting number. And that's basically what we're doing. We're using inverse operations to find the value of our variable. So we have a variable n I'm thinking of a number, I multiplied by 3, I added 7, and I got to 28. What did I start with? So this is what, right? So to solve this, I'm going to first subtract 7, divide by 3, and that will lead me to my original number n. So that's, again, this is just a little guide that's going to help me with the steps that are necessary with the inverse operations that I'm going to do to solve and find the value of n. So again, line in the middle. If you want, you can do it. First thing I'm going to do is right here. Subtract both sides by 7. So subtracting both sides by 7 gets rid of this constant here. The 7 goes away. And I'm left with 3n equals n21. Now the second thing I do is right here. Divide both sides by 3. Divided both sides by 3 isolates my variable. Look. Instead of 3n, now I have 1n. And 21 divided by 3, 7. Now check. You must do the check. So I'm going to replace n, our variable n, with 7. And it's not enough for you to just leave it like that. I actually want you to go one step further. 3 times 7 is 21 plus 7. And just guarantee or double check that 21 plus 7 is indeed 28, and both sides equal each other. This is the solving part. This is the checking part. This is just, I don't know, call it your guide, your story, your little map. Right? It tells you step 1, subtract 7 from both sides. Step 2, divide 3 on both sides. And this is a two-step equation because we did 2 steps, right? 2 inverse operations to get to our answer. Explain the first step you took. Well, the first step that I took was subtract 7 from both sides. All right, and explain why you took this first step and how this step helps you solve an equation. Because much more. Subtract 7 from both sides. I wanted to eliminate the constant first, right? And a constant, again, if you look at your equation, 28 equals 3n plus 7. I mean, the number multiplying the variable is called the coefficient, right? And then this number here is called the constant because it never changes. It's forever and ever. 7. So I wanted to eliminate the constant first, right? Which is what we do, get rid of the 7. And then eliminate the variable. Sorry, the coefficient. Coefficient in order to isolate my variable. In order to isolate my variable. Alright, so that's all those fancy words in there. Moving along. Again, same thing. So again, let me do the little story here. Here's a number that I'm thinking of, n. I divided first by 4. I subtracted 7, and somehow that gave me 5. So what number did I start with? Well, going backwards, right? The inverse operation I'm going to use to solve this equation is I'm going to add 7 to both sides, and I'm going to times 4 to both sides. So let's see, 5 equals n over 4 minus 7. So line in the middle divides my equation into 2 expressions. I'm going to add 7 here. Adding 7 gets rid of this 7 over here, right? And I'm left with just an n over 4 equals 12. Next thing is multiply both sides by 4. If you multiply both sides by 4, now I can simplify these two 4s and give me 1, and 1 times n is just n. So there I have my variable all isolated, just 1n, and 4 times 12 is 48. So I am assuming that's my answer. I go back to the original equation, replace the n with 48. I'm going to write 48 over 4 minus 7, and that hopefully gives me 5. So 48 divided by 4 is 12, and then I'm going to subtract 5, and notice that my left side and my right side equal each other. We are good. 3, again, at some point you're going to be saying this is tedious, and I agree with you. So I have a variable c, which I divided by 2. I subtracted 8, and somehow it got to me to negative 3. Inverse operations, I'm going to add 8 to both sides, and then I'm going to multiply 2 to both sides to give me my value of c. So let's follow that. Change colors. Line in the middle. This is the left side of my equation, right side of my equation. We're going to add 8 to both sides, and it's right here. I don't have to guess anything. Once I have this story, my math, my guide set up. It says here, step 1, add 8 to both sides. Done. These two 8s cancel each other out. I'm left with c over 2. Negative 3 plus 8 is 5. The next thing I'm going to do is right here. It says multiply both sides by 2. This and this simplifies. I'm left with c, and 5 times 2 is 10. So apparently that's my answer. Let's verify. So in place of c, I'm going to replace it with 10. I'm going to write 10 over 2 minus 8 equals negative 3. 10 over 2 is the same thing as 5, and then 5 minus 8 is negative 3. And indeed, it is. 5 minus 8 is 3, and negative 3 on the left side equals negative 3 on the right side. Ta-da! When solving the equation in question 3, how did you use the concept of additive inverse? So let me go back to the picture. So, right, I use the concept of additive inverse over here. Right, so the additive inverse of negative 8 is plus 8, and I use the concept of additive inverse to get rid of the minus 8, thus getting closer to eliminating, to isolating c. Right, so here's my original equation: c over 2 minus 8 equals negative 3. So the additive inverse helped me get rid of this guy over here. Oops, let's pick a lighter color to eliminate the negative 8, right? Because I did the additive inverse of negative 8 was plus 8, and then those two are zero pair, right? And that gets eliminated. So once I got rid of the negative 8s, I could concentrate, or I could focus next to eliminating 2 here under C. Okay. 5. Okay. Now 5 is a little special, right? So again, I would write a 1 here. You don't have to, but in this case I would, because it really does help. Here's my variable d. It's being multiplied by negative 1, which I then added 9, and somehow it gave me 11. Going backwards, I'm going to subtract 9, and I'm going to divide both sides by negative 1. So let's do that. So now, I did that so that it helps you on the map. You don't have to, but let's do it without. That's eventually what you're going to do anyway. So first thing, divide both sides. My left side, my right side, I'm going to subtract 9 here, subtract 9. 11 minus 9 is 2. These two 9s, right, then the additive inverse of plus 9 is minus 9, so this becomes 0. And then I'm going to bring down negative d, Now, I want to make that variable positive, and in order to do that, remember, now I'll put the 1 back here, so I guess you can understand. So next step says divide both sides by negative 1. Divide this side by negative 1. Divide this side by negative 1. Well, negative 1 divided by negative 1 is positive 1, and positive 1 times d is just d. Isn't that what I wanted? And then 2 divided by negative 1 is negative 2. So this is the value of d. Let's check. Now I'm going to actually write this, because substituting is another. So now be very, very, very careful, because a lot of past students will say, well, these negative 2, so there it is substituted. That's not true, because that minus sign here, it has nothing to do with the negative sign for the 2. So if you understand what substituting is replace. So think about it. I'm going to take this d, the letter d out, and replace it with negative 2. So, but before I do that, let me write everything that's already there. Everything that's already there is that minus sign plus 9 is 11. So if you if I could, with my fingers, take the letter D out, and then I'm going to replace that with negative 2. Because the number is negative, I'll put in parentheses. So this is what you have. Now, negative and negative is a positive, so that becomes 2 positive plus 9 equals 11, and then 11 equals 11. Ta-da! And B, how did you eliminate the negative sign in front of D? Well, how did we do that? Well, we multiply it by negative 1 because the coefficient is negative 1. And dividing by another negative, because both are negative, I get a positive, and then that's how D got to be positive. Okay, so that's a little tricky question. Okay, and I really think that putting a negative 1 in front of D, the coefficient visible, it helps you. Error analysis. Let's see, 13 equals 10m plus 8, and Danny thinks that m equals 2. Let's see, the first thing we did, so let me translate this over here because it's written vertically. Sorry, horizontally. So notice that that person subtracted minus 8 on both sides. Okay, so let me split the equation into 2 parts. Minus 8, minus 8. So that looks okay. 13 minus 8 is 5. So up to here, check, check on the left side. This goes away. 10m brought down. And that's a check. And then, if we do it, what's the next step? Well, the next step should be divide by 10, right? You can't divide by 5. If you divide this by 5, you get 10 divided by 5, which is 2m, which is not what we want. We don't want 2m, right? We want m. We want m isolated with a coefficient of 1. So dividing by 5 doesn't really get us to our goal. So here, we should divide by 10, which means that we have to divide the other side by 10. 10 divided by 10, look, that gets me to m with a coefficient of 1. And on the other side, 5 divided by 10 is just 0.5, or if you want a half, that's completely fine. So do you agree with Danny's answer? No. How can you check if Danny's answer is correct? Well, how could we check? We could have tried this. So here's the equation, 13 equals 10m plus 8. And Danny said m was 2, so 13 equals 10 times 2 plus 8. 13 equals 10 times 2 is 20 plus 8, and we can already see that the answer is not, left side is not equal to right side, so that's incorrect. So m equals 2 is the correct answer. So how can you check? We can just substitute, replace m with 2, and we could have just found out. What mistake did Danny make? Well, the mistake that Danny made, that over here, I'll highlight it over here, this, in this section, I'll circle it. This section over here. From here is her mistake. Instead of dividing both sides by 10, she divided both sides by... Actually, I don't know what she divided by, because how did she get 2? Well, she was supposed to divide by 10. Did she divide by 5? Yeah, I think she divided by 5, and then she actually did this. 5 equals 10m. She divided by 5 and divided this by 5. This got crossed out, simplified to 1. And she got 2m over here, and then she just transferred the 2 to the other side. No idea what she did. But instead of dividing by 10, she divided by 5. So that's her mistake. Okay. What's the correct answer? The correct answer is half or 0.5. So that was your first part, which most of you probably finished in class. We had this, which hopefully you're looking forward to. A lot of these problems. Now, I'm not a particular fan of you doing equations, multi-step equations, and you always get the answer as 4, x equals 1, x equals 8, or x equals negative 2, and then you come here and plug it in. Because that's not really... let me represent the type of equations you may encounter later on. Not every equation is going to be a nice, pretty whole number. Right? Sometimes they come in this format, this format, or this format, right? It creates more of a pain, but but there's nothing we can do about that there. So in this case, we're not ready to create that little story, right? So what we're going to do is use all the tools that you've been working on the past week or so, combining distributive property and simplifying this expression. That's our goal right now. So how do we make this? Well, so first of all, I can't combine these two. So on the left side, I'll leave this like as it is. Minus 11 over 3r equals negative 7 over 4r minus, and I'm going to do the distributive property here. So negative times a negative, so actually it's going to be plus 5/4. So let's take a look at 5/4 times 4/3 r. This simplifies, and then I get, I'm left with 5 over 3r. Done. The second one, negative times a positive, it's going to be a negative, and 5/4 times 1 is just negative 5. We have options here, right? We have options. I can combine these two r's and then, move this r to this side. And there's a lot of things I can do. So the first thing I'm going to do is get rid of that denominator. Pretty sure you don't want to work with fractions. So we need to find a common denominator between 16, 3, and 4. 16, 3, and 4. So we're going to change that. So the common denominator between 16, 3, and 4 is 48. Is it? Yes. So what we can do, I'm going to put a big parenthesis here, and I'm going to put 48. And we're going to multiply 48 times every single fraction on the left side as well on the right side. And that's going to get rid of the fractions, and then I don't have to deal with it. So let's do the first one. 48 times negative 149 over 16. Well, 48 divided by 7. So if you divide 48 and 16, first of all, that's going to give you a 3. And then if you multiply 149 times 3, 7, carry 2, 14, goes 1. So we get 447 negative. 48 times negative 11 over 3. I am going to, hopefully, and so are you, please use a calculator. So what ends up happening here, when you multiply 48 times 11 over 3, okay? First of all, you get a negative. Then 48 and 3 can simply divide to 16, and 16 times 11 is what you need to do in your calculator. You get 176r equals 48 times negative 7 over 4. Well, 48 divided by 4 is 12. 12 times 7 is 84. That's negative 84r. 48 times positive 5 over 3. Well, first of all, it's positive. 48 divided by 3 is 16. 16 times 5 is just 80. So up to these two, you don't need a calculator. And the last one, 48 times negative 5 over 4. It's going to be negative. 48 divided by 4 is 12, and 12 times 5 is 60. We got rid of our fractions. So much easier to deal with. Now, let's combine like terms, and this is maybe something that you haven't done. So on the left side, I can't combine those two because they're different. Has a variable of r, and the other one is just a constant, so I can't combine these two. On the right side, I can combine these two. I get negative 4r minus 60. Notice that we have variables on the left side and variables on the right side. So this is, again, something that, sorry, that's my wife. Yeah, a second. All right, so where was I? So now we have variables on both sides. When you have variables, so every equation that you've solved, like the ones that we did in class, you have like say 2x plus 5 equals 12. Notice that variables on this side, no variables on that side, right? So we have an issue here. So what we have to do is have all the variables on one side and all the constants on the other side. Okay, so what we can do here is, let me do this first. Draw a line in the middle. So imagine what we do here. So remember in the equation, if you're thinking of an equation and keeping it balanced, so the left side and the right side has a balance. Now, if I do this, if I add 176r to the right side, I need to add that same number, sorry, on the left side, I need to add the same number to the right to keep it balanced. Right? Now, watch what this does. By doing that, Negative 447. Well, that doesn't do anything because there's nobody to add with. But negative 176r plus 176r, they're additive inverse. So that goes away, right? And we don't have any r's on that side anymore. But on the right side now, I have negative 4r plus 176r. They're like terms, and I can add that, and that gives me 172r minus 60. Finally, we get to the point where we can do a little story, right? This is a two-step equation. You should recognize it. I have a variable r that I multiply by 172. I'm going to subtract 60, and that's going to give me negative 447. All right. The two inverse operations I'm going to need is add 60 and then divide by 172. God, I hope this works. So let's do that. Let's get rid of this 60 first by doing plus 60. And if I do plus 60 on this side, I must do plus 60 on the other side. That's 172r. This equal to 0. And on this one, if I add negative 447, right? Negative 447, 387 is my answer. Negative by 40. And then I'm going to divide both sides by 172. And r, and this goes away, so r equals negative 387 over 172. Look how pretty that answer is. Okay, so I can take this now, and this is the part where we all start crying, including me. And we got to plug it in here. Here, and here, and here in the original equation. So I'm going to do that. What's my answer again? 387 over 172. Let me write this over here. 387. 172. Can I simplify that? Let's see. That's not divisible by 3. No. So, negative 149 over 16. Now, you're going to say, Mr. Cho, can I substitute in here, right? You could, theoretically. But the problem with substituting this answer in this equation where we eliminated the fractions is this. What if I did this step incorrectly? What if I messed up here? So when I substitute this in a simplified equation, I might get the wrong answer or might not get the right answer. So it's always best to simplify it, so to replace substitute in the original one. Therefore, we don't have to worry about any mistakes. So negative 11 over 3 times 387 over 172 equals negative 7 over 4, and you will have a calculator, times negative 387 over 172. Ugh. This. Copy. Paste. What? There you go. Sorry. Alright, so that's the original equation. We're substituting, right? We're making sure. So negative 149 over 16 minus 11 over 3 times r, and this is r, which is, I'll put in parentheses, negative 387 over 172. Don't worry, you will have a calculator when you're doing these problems, okay? So the tiers, you can save them. Minus 5 over 4, negative 4 over 3 times negative 387 over 172 plus 1. Got it. So I, in my defense, will get a calculator. So let's see. That amount. So this, like I said, does nothing. So we need to find some values first. This is going to be a positive. So in your calculator, you would put 11 over 3 times 387 over 172. Press enter. Simplify. Simplify, and you get 8 1/4. So all that is 8 1/4. Oops. Okay, so just out of curiosity, let me see if I can simplify 149 over 16. I can. So, well, we'll talk about that later. Now let's multiply this. So it's a negative times a negative, so that's going to give me a positive. So it's 7 over 4 times 387 over 172. Oops. So just got to bear with me. 7 over 4 times fraction 387 over 172. Enter. Let's simplify this, and we get, so this here becomes 3 15 over 16 positive, and then we got to do the parentheses, so we have negative 5 over 4, and we got to put this into parentheses, so put that in the calculator, so we get, so again, it's a negative times a negative, so it's going to become a positive, so 4 over 3 times 387 over 172, enter, and then plus 1, enter, so that all equals to 4. So let's actually do this on the right side. And 149 over 16 plus 8 1/4. Enter. We're going to get this to the left side equals negative 1 over 16. And for the love of God, I hope the right side. So we have, and again, this simplifies, right? So that 4 and 4 simplifies. So we actually, in the calculator, we're going to put clear 3 15 over 16 minus 5, right? Because the 4 and the 4 simplifies. So, oh, look at that. And there's our check. Okay, you can scream now. But that's the work, and hopefully, and luckily, I also did it correctly. All right, now moving along, you had this little page to do, and we had the evens. Okay, so I'm just gonna do this pretty quick. The evens should not be an issue for you. I'm gonna write the story. So it's story check solve, right? So we have a variable x, which is being multiplied by 4, subtract 6 is giving me negative 5, so we're going to do plus 6 and divide by 4. So again, after today, if you're super confident, this, you don't need it, right? But this clearly shows the steps, the inverse operations that I have to do to solve the equation. So here is my line in the middle. I'm going to add 6 to both sides, and where do I get that? It's right here. It's the inverse operation of subtracting 6. So I do plus 6. So that makes these two go away. X over 4 is left over. Negative 5 plus 6 is 1. Second thing I do, it's divide by 4, which is the same thing as multiplying by 1 over 4. Sorry, by 4, right? So think about, let me show you that. So dividing by 4, in this case, x over 4, divide by 4, becomes x over 4 times, oh, my mistake. I did the story wrong. So it's, here's the variable x. It's being divided by 4 and then subtracting 6, which gives me 2, negative 5. So the inverse operation is adding 6 and then times 4. Okay, that makes better sense. So we did the plus 6 on both sides. Now we multiply both sides by 4. This goes away, becomes 1, and x equals 4. Check. We have negative 6 equals negative 6 plus, so we replace the x here with 4, plus 4 over 4 equals negative 5. Is that true? Well, negative 6, 4 over 4 is 1 equals negative 5. We combine these two, we get negative 5 equals negative 5. Perfect. Second one, story. N is my variable. It's being divided by 5 to then I add 4. Somehow it gives me 0. What did I start with? Well, let me subtract by 4 and then multiply by 5. So subtract 4, minus 4, minus 4. The 4's will go away. On the left side, 0 minus 4 is negative 4, and then I'm left with n over 5. Done. Now it tells me to multiply both sides by 5. That becomes 1, and n equals negative 20. Let's check. 0 plus 0 equals 4 plus, and let me replace the n with negative 20 over 5. 0 equals 4 plus, and what's negative 20 over 5? Negative 20 over 5 is the same thing as negative 4. And 4 plus negative 4 is 0. Very good. Okay. We're just doing the evens, okay? That's a great idea with that. Here. Oh, something that you haven't seen, but let me write this a little bit better. So negative 1 equals 5 plus x over 6. Now, in that previous example, the big long one that I did, we said we can get rid of the, what do you call, of the fractions. How do I get rid of the fractions? So if you want to deal, and we'll talk about this later a little bit more, and we're going to multiply everybody by 6, right? So this, if I multiply 6 times, so it's going to be this times this and this times that, because this is one whole thing. Okay, so 6 times negative 1 is negative 6, and then if I multiply 6 times 5 over x, sorry, that should be an x over 6, this 6 and this 6 eliminates, becomes 1, and I'm just left with 5 plus x. That's one way of doing it. The other way you could have done is cross multiply. 5 plus x over 6, and then you can put this over 1, and you can cross multiply this, cross multiply this. And if you notice, you're going to get the same exact thing. So, in this case, it's probably easier to just cross multiply. Now that you cross multiply, you can set up a little story. Here's my variable x. Somebody added, so here's a number that I'm thinking. I'm going to add 5 to it, and I get negative 6. What number did I start with? Well, what's the opposite? The inverse operation of adding 5 is subtracting 5. So line in the middle separates my equation into 2 expressions, the left side and the right side. So it says here, subtract 5 from both sides. Well, that goes to 0. X equals negative 11. So the answer says it's negative 11. So let me, over here, I have negative 1 equals 5 plus negative 11 over 6. Negative 1 equals, what's 5 plus negative 11? That equals 2, negative 6 over 6. Negative 1 equals, and 6 divided by 6 is 1, but it's going to be negative. Are we right? Yes, we are. Number 8, we have a little distributive property to do before we do a little story. So we get 2n plus 10 equals negative 2. I have a variable n, a number that I'm thinking of. I multiply by 2, I add 10, and it gives me negative 2. What did I start with? Well, let's subtract 10 from each side. Let's divide 2 to each side, and that's how I'm going to find my answer. So first thing, subtract 10, subtract 10. 10 minus 10 is 0. I'm left with 2n on the left side. Negative 2 minus 10 is negative 12. Check. Now I divide both sides by 2. 2 divided by 2 is 1. I'm left with n. And negative 12 divided by 2 is negative 6. Check. So 2, and I'm going to, instead of n, I'm going to replace with negative 6 in parentheses. And let's see if that really equals negative 2. Well, let's do the parentheses. Negative 6 plus 5 is negative 1. What's 2 times negative 1? It is negative 2, which equals negative 2 on the other side. Good. 8 is done. 10. Shoot. Quite a lot. So 10, let's see, again, 10, I have a variable called n. I'm dividing it by 2. I'm subtracting 10, and it gives me negative 6. Inverse operations, I'm going to add 10 to both sides and then multiply by 2. So let's do that. Negative 6 equals n over 2 minus 10. I'm going to add 10 to the right side and plus 10 on the left side. Negative 10 and 10 is 0. I'm left with n over 2. Negative 6 plus 10 is 4. Now it tells me to multiply this side by 2 and multiply this side by 2. These two simplify to 1. I'm left with n. 2 times 4 is 8. So I got 8 as n. Go back to my original equation. I got negative 6. And over here, I'm going to go 8 over 2 and then minus 10. Oh, negative 6. 8 over 2 is 4 minus 10. And then it's negative 6. And 4 minus 10 is negative 6. Done. Again, before you make the story, do a little distributive property. We get 144 equals negative 12x minus 60, right? Negative and a negative, negative and positive and negative, and negative and positive and negative. Now, all that work last week, guys, it's all coming to fruition. Here's I'm thinking of a number x, which I multiplied by negative 12, and then I subtracted 60. It equal to 144. And I add 60 to both sides, and then I'm going to divide both sides by negative 12. So those are two inverse operations I'm doing. So equation, separate in the middle. Let's add 60 here. Let's add 60 here. Plus. This goes away. I'm left with negative 12x, which is, 204, positive. Then I'm going to divide this side by negative 12, and divide this side by negative 12. That gives me positive x, and 204 divided by 12 is 17, negative. That's my answer. X substituted, 144 equals negative 12, and inside the parentheses I'm going to put negative 17 plus 5, right? I'm replacing x with the value we just found. 144 equals negative 12, negative 17 plus 5 is negative 12. 144 equals, what's 12 times 12 is 144, negative times a negative is a positive. So the only thing I guess we use these problems today to just practice the steps, right? I'm just not too keen on the answer always being a nice integer, right? Okay, a few more. V is my variable. I'm multiplying by negative 6. I'm adding 10 to it, and somehow it gets me to negative 104. Subtract 10, and then divide by negative 6 are the two steps I'm going to do. So let's subtract 10 here, and let's subtract 10 here. Those goes away. I'm left with negative 6v equals negative 114. Divide both sides by negative 6. Negative and negative is positive 1. And then 114 divided by 6 equals, no idea. Gives me 24. Positive. In the original equation, which I can't see, I'll replace the v with 24. So 10 minus 6 times 24, this is my replacement, equals negative 104. 10 minus, this is negative 114, right? 6 times 24 is negative 114 equals negative 104, and look at that. They equal each other. Good. 16. X is my variable. I'm multiplying that by negative 9. I'm subtracting 13, and I get negative 103. I'm going to add 13 to both sides and then divide both sides by 9 to find the value of y. So add 13 here, add 13 here. That goes away. I'm left with negative 9x equals 90. Negative, by the way. And then divide both sides by negative 9. And x equals positive 10. Let's see if that works. 9 times, and I'm replacing this x with 10. That's negative 90, right? And these two minus 13 equals negative 103, and yes, we are good. 18. By now it's being very repetitive, right? So variable is m, it's being multiplied by 7, you subtract 10, and then somehow it gives me negative 10. Inverse operation number 1 is plus 10, and the second one is divide by 7. Okay. Plus 10 on this side, plus 10 on this side. So we got 7m, because these two go away. These two do also go away, but you can't just leave it at blank. You actually have to write 0. Next thing is divide this by 7 and divide this by 7. Well, that isolates my variable. I'm left with m, and 0 divided by 7, or 0 divided by any number is going to be 0. Well, let's see if that works. Negative 10 equals negative 10 plus 7 times 0, right? Right here, I'm replacing the m with 0. Negative 10 equals negative 10, and 7 times 0 is just 0, right? So this is 0. I don't even have to write 0 over here. And we know that the left equals the right. Check. Variables m being divided by 9, and subtract 1, and that's going to give me negative 2. First inverse operation is plus 1. The second one is divided by 9. So left and right expressions. Left 1, right 1, plus 1, plus 1. That simplifies to 0. I'm left with m over 9. And negative 2 plus 1 is negative 1. Well, now I'm going to, sorry, it should be times. What do I do? Times 9 on both sides. That simplifies right to 1, giving me m. And the other one, negative 1 times 9 is negative 9. Let's see if I'm correct. The original equation, we're going to replace this m with negative 9. So negative 9 over 9 minus 1 equals negative 2. Negative 9 divided by 9 is negative 1. Negative 1 minus 1 equals negative 2. And negative 1 minus 1 is indeed negative 2, which matches to negative 2 on the other side. Good. 22. I have to do the distributive property first. So that is going to give me 63 plus 7k equals 84. K is my variable. I'm multiplying by 7 and then I'm adding 63. That's going to give me 84. So the first inverse operation that I need is minus 63 and then divide both sides by 7. So let's subtract 63 here. Subtract 63 here. That goes away. 7k is left over on the left side, and 84 minus 63 is 21. Done. Now divide both sides by 7. K equals 3. So to make that equation true, they're saying that this k here has to be 3. Well, let's substitute. 7, 9 plus 3 equals 84. 7, 9 plus 3 is 12 equals 84. Let's multiply 7 times 12. It is 84, which equals 84 on the other side. Last question. Again, distributive property here, so let's do it. So we get negative 243 equals negative 90 minus 9x, right? Because the negative and the positive is a negative, and then negative and then positive against a negative. Here's my variable, it's called x. Somehow somebody multiplied it by negative 9, and then we subtracted 90. First inverse operation is going to be to add 90 to both sides and then divide both sides by negative 9. So let's follow those steps. Left and right. It says add 90 first to both sides. That goes away. I'm left with negative 9x. On the other side, what is that? 153? Yep, negative 153. Divide that by negative 9, because right here it tells me to divide that by negative 9, which means I have to divide the other side by negative 9. So 153 divided by 9. Well, first of all, this and this simplifies to x, right? Negative is positive. And this is also going to be a positive, and x equals 17. Well, let's see if that's true. So I have negative 243 equals negative 9, and then I have 10 plus 17, right? Because I'm replacing this x with 17 right here. Negative 243 equals negative 9. What's 10 plus 17? It's 27. Yes. And then let's just multiply 9 times 27. Negative 23, and if you multiply negative 9 times 27, you also get 240. And you know you're correct because the left side of your equation matches the right side of your equation. Alright? Alright, that's it.